In this session, we're going to look at vector applications again, but this time we're going to look at tension. Force is also represented by a vector. We can think about it as the push or the pull on an object. In particular, tension in a cable is a force that has both magnitude and direction. Example, a 200-pound weight is suspended from the ceiling, attached to two cables as shown. And the question says we want to find the tension on the cables. Here's the diagram. This is the ceiling, and we have the first cable makes an angle of 50 degrees from the ceiling. And here's the weight. And the second cable is attached to the ceiling at an angle of 30 degrees. Tension in the first cable, and the weight acts downward. So we can set up a free body diagram to resolve this problem. We have our weight acting downward. We have the tension in the second cable, tension 2, and the tension in the first cable, T1. This angle is 30 degrees, and this angle here is 50 degrees, and this angle here is 30 degrees as well. Two parallel lines cut by a transversal. And because this object is stationary, this object is in equilibrium, in other words, all the forces must balance. The tension in the first cable plus the tension in the second cable plus the weight of the object all add together to give the zero vector. So this is our vector equation. Find the actual vectors, or we can think about this problem in terms of the components, the horizontal components and the vertical components. They also must balance out. If we look at the vector T1, this angle here is 50 degrees. The horizontal component would be the magnitude of T1 times the cosine of 50 degrees. The horizontal component of T2 is the magnitude of T2 times the cosine of 30 degrees. T2 here, and this is 30 degrees, and here's my horizontal component. Those two horizontal components must equal each other because this system is in equilibrium. It's not moving. Our first equation, and we can take that equation and solve for the magnitude of the tension, T sub 1. This is going to equal the magnitude of the tension, T sub 2, times the cosine of 30 degrees divided by the cosine of 50 degrees. Set that aside for now and look at the vertical components of the force. The vertical component would be T1 times the sine of 50 degrees. And the tension in cable T2 is the magnitude of T2 times the sine of 30 degrees. And then we have the weight that is downward. This is up, and this one is up, and then our W points downward. The sum of all those must equal 0. In other words, the vertical components that are pointing upward, magnitude of T1 sine of 50 degrees plus the magnitude of T2 sine of 30 degrees, sum of the forces in the vertical direction pointing upward, they must equal the weight of that object. So there's the second equation. Our two equations again, let me write it down here, was that magnitude of T1 cosine of 50 degrees is equal to the magnitude of T2 times the cosine of 30 degrees. And the second equation for the vertical components, the magnitude of T1 times the sine of 50 degrees plus the magnitude of T2 times the sine of 30 degrees is equal to W. This forms a 2 by 2 system of equations. The goal is to solve for the two unknowns, the magnitude of T1 and the magnitude of T2. So we're going to use the method of substitution. Here's a variable that we are going to substitute into the second equation here. Magnitude of T2 times the cosine of 30 degrees over the cosine of 50 degrees times the sine of 50 degrees plus the magnitude of T2 times the sine of 30 degrees is equal to W. So here we want to factor out the magnitude of T2, and the second step would be to solve. for that magnitude T2. Factoring out the magnitude of T2, we have the magnitude of T2 times parenthesis cosine of 30 degrees times the tangent of 50 degrees plus the sine of 30 degrees is equal to W, the weight of that object is 200 pounds. Divide cosine of 30 times the tangent of 50 plus 30 degrees. We come up with an expression. The magnitude of T2 is equal to 200 divided by, parentheses here, cosine of 30 degrees times the tangent of 50 degrees plus the sine of 30 degrees. And now that we have that value, we can find the magnitude of the tension in T1. So the magnitude of T sub 1 is equal to the magnitude of T sub 2, 200 divided by the cosine of 30 times the tangent of 50 plus the sine of 30 degrees. And then we're going to multiply that by cosine of 30 degrees divided by the cosine of 50 degrees. Now it's just a matter of computing those as decimals. Typically the question will tell you what places to round it to. Computing the value on the calculator, the magnitude of the tension in cable T2 is approximately 130.54 pounds. And the magnitude of the tension T sub 1 is approximately 175.88 pounds.